Hello everyone, my name is Vivek Srivastava, Assistant Professor, Computer Science and Engineering Department, ABES Engineering College, Ghaziabad. Today, I am here to deliver a lecture on Introduction to Bayesian Belief Networks, which is a very important concept in machine learning techniques. So, before going in the deep discussion, we must know about what is Bayesian belief networks. Bayesian belief networks, also known as Bayesian networks, are graphical models that represent probabilistic relationship between nodes and set of variables using directed acyclic graph, which is also known as DAG. In Bayesian belief network, we have two components. Number one, nodes, and number two, arcs. Node represent the events and the arc represent the conditional probabilities between the events. We can use Bayesian belief network to solve very complex problems and in various areas like probabilistic reasoning, decision supports, complex system modeling, learning from data also. So Bayesian belief network is very useful and significant in the field of machine learning. Bayesian network graph is made up of two things. As I told earlier, the Bayesian graph is made up of two things. Number one, node, and number two, arcs, which can be represented like this. Suppose there is a node A, B, C, and D. So there are basically four nodes which can be represented as the random variables, or these variables can be continuous or discrete. The arcs, like from A to B, A to C, B to D, and B to C to D, it represents the causal relationship or conditional probabilities between random variables. These directed links or arrow connect the pair of nodes in the graph. If you see in the given graph, then there are four random variables A, B, C, and D, which is called the nodes of the graph. If we here consider node B, which is connected with node A by a directed arrow, then node A is called the parent of node B. But if we consider node D, then there is no relationship between node A and D because it is not directly connected. So here we will consider only the nodes which are directly connected, or child and parent relationship. Now we can take an example of Bayesian belief network and understand how actually this works. But before moving forward, moving towards through the example, we must know the construction of Bayesian belief network. So there are basically 5 steps. Step 1. In step 1, Bayesian belief network, building a basically we have to define the problem and identify the variables. What are the variables? What are the major components which can be useful for building the Bayesian belief network? Then determine the causal relationship or conditional probabilities between the variables, random variables. Like in previous example, we have considered A, B, C, and D. Then A, B, C, and D are the nodes, which are the random variables. We have to determine the causal relationship between them. Create the graphical structure, which I have already created in the previous diagram. Assign probabilities using expert knowledge or data. The data or knowledge is given in the problem statement. You have to just follow the instructions given in the problem statement, and perform inference and update probabilities. So these are the things which can be used while using Bayesian belief network. Now I will explain this by an example. So the problem statement is given as calculate the probability that alarm is sounded, but there is neither a burglary nor an earthquake occurred, and Dennis and Sarah both called the person. Okay, so this is the scenario. Now, how will we solve these type of problems using Bayesian belief network? Let's understand step by step. The solution of the given problem can be considered as the Bayesian network for the above problem is given, as we all can see in the screen. The network structure is showing that burglary and earthquake is the parent node of the alarm and directly affecting the probability of alarm going off. But Dennis and Sarah call depend on the alarm probability. Okay. Second thing, the network is representing that our assumptions do not directly perceive the burglary and also do not notice the minor earthquake, and they also not confer before calling. Third thing, the conditional distribution for each node are given as conditional probability table or CPT. Each row in CPT, conditional probability table, must be sum to 1 because all the entries in the table represent an exhaustive set of cases for the variable. And last point, in CPT, that is conditional probability table, a Boolean variable with k Boolean parents contains 2 to the power k probabilities. Hence, if there are 2 parents, then CPT will contain 4 probability values. Got it? So, what are the list of events here? There are total events, list of events: burglary B, earthquake E, alarm A, Dennis calls D, and Sarah calls S. These are the events. We can write the events of problem statement in the form of the probability like this. We can write it like this. I'm going to write it here. Probability of D, S, A, B, and E. So we can write the events of problem statement in the form of probability like this. We can rewrite the equation in different forms depending on the condition which we are going to take here. Okay. Now let's take the observed probability for the burglary and earthquake component. These are the given values. We don't have to compute this. These values are based on the observations. Probability of burglary to be true is equal to 0.002, which is the probability of burglary, and probability of burglary to be false is 0.998, which is the probability of no burglary. In the same way, we can see the observed value related to earthquake and earthquake happened or not is given in the form of probability. Now let's have a look of conditional probability table for alarm A. Since alarm have 2 parents, burglary and earthquake, so the truth table or conditional probability table of alarm will contain 4 rows. These are the values: burglary true and burglary false, earthquake true, burglary true, earthquake false, burglary false, earthquake true. These are the observed value. These are the basically given value. Now consider the conditional probability table for Dennis calls. When the conditional probability of Dennis calls, then he will call depends on the probability of alarm. So the given values, if alarm rang, if alarm sounded properly, then there are two things, true and false, and the value associated like Dennis calls, if the alarm rang, is 0.91, and if alarm rang and Dennis doesn't call, the probability is given as like 0.09. In the same way, we can see the if the value of alarm to be false, then probability of Dennis call is 0.05, and probability of Dennis call is not call is 0.95. See, in the same way, conditional probability table for Sarah calls is also given based on the parent class, and Sarah and Dennis have only one parent like alarm. Okay, so these are the conditional probability table, which is also considered as CPT. Now, from the formula of joint distribution, we can write the problem statement in the form of probability distribution, which is written like this. Closely observe this formula. This formula. So clearly observe this formula. Probability of S, D, A, not B and not E. So this statement is given as that Sarah calls, Dennis calls, alarm start ringing, but burglary and earthquake doesn't happen. So we can solve this type of problem by considering the values of the observed value. So now we have to find the probability of S. If we are going to find the probability of Sarah call, then it will calculate the probability with respect to its parents. So Sarah oblique A multiplied by Dennis oblique A, that is alarm, multiplied by alarm oblique not B and not E, multiplied by probability of not B and multiplied by probability of not E. So we have written here like this: probability of S oblique A. Now check how we are getting this value. Like we have to check the conditional probability table of Sarah. Now check the conditional probability table of Sarah. Sarah calls. We have to find the probability of Sarah calls when alarm rang. So alarm value should be true. Alarm value should be true. And probability of Sarah calls to be true. So the common value which we are going to get is 0.75. So we have written 0.75. In the same way, we can write the value of Dennis oblique alarm. So we can check it with the table of Dennis. Here, value of Dennis calls is true. Value of alarm is true. So the intersection value is equal to 0.91. We have to put this value 0.91. Now we have to find the value of alarm with respect to not B and not E. So we have to check the table of alarm where both the value burglary and earthquake should be false and the value of alarm to be true. So the intersection value is equal to 0.001. So we have written this value here. Now multiply this by probability of not B. Not B, that means, one second, okay, 0.998. So this value is given like this: probability of burglary to be false is equal to given as 0.998, and probability of earthquake to be false is given as 0.99999. So we have multiplied all these values. After multiplying all these values, we will get a final value which can be considered as our answer. And in our case, we are getting the value, we are getting the probability of Sarah calls, Dennis calls, alarm ranks, burglary doesn't happen, earthquake doesn't happen, is equal to 0.000068045. So in the same way, we can solve a lot of problems. Suppose if someone asks you to find the probability of, suppose Dennis calls, Sarah doesn't calls, alarm turned on, burglary happens, and earthquake not happen. Then what will you do? You will simply check the probability distribution, conditional probability table of Dennis, Sarah, alarm, burglary, and earthquake, and you will get the values and just simply multiply them, and after multiplying you will get the final answer. So this is the very simple technique by which we can solve the problems like with the help of Bayesian belief network. I hope you have got the solution perfectly, and I hope in the next lecture I will be delivering more content related to machine learning topics. And thank you for watching this video. Good luck.